Okay, peeps, I'm back for this week. We'll be basically summarizing everything on probability that you've done. Um, I'll go through this question, which is in your exemplar 2014, where they say you're given that events A and B they are mutually exclusive. Right. That's the first thing that you should read, that your events whether they're mutually exclusive or they're inclusive. So in this question you're given that A and B are mutually exclusive, and then they further give us that the probability of B is 2 times the probability of A, and then they also give us the probability of A or B being 0.57, and then the question says calculate the probability of B. Okay, so to calculate the probability of B here, okay, just mark this first statement which says A and B are mutually exclusive. What does this tell you when they say events are mutually exclusive? It tells you that the probability of A and B is equal to 0. Where do I get this? Okay, if your events are mutually exclusive, I'll just explain the mutually exclusive part. Okay, this is I've got two different Venn diagrams here. I've got my Venn diagram H, and then I've got my Venn diagram I. Okay, on my Venn diagram H, or my sample space H, I find two events that are mutually exclusive. Why am I saying these events are mutually exclusive? It's because they have no intersection. There's nothing that there's no place where both these events intersect. Okay, so we know that we represent intersection by the word and. The word and probability, it refers to your intersection. But when you go to sample space I, you find two events that are inclusive. Why am I saying they're inclusive? Because your and, which is your intersection, is there. It is present. There is a common event between your two events that you've got on your sample space there. Which means that is why, and I said your probability of A and B is going to be 0 if your events are mutually exclusive, because there's absolutely nothing that um, make these events to intersect. So remember also that you just think of your addition rule, which says the probability of A or B equals to the probability of A plus your probability of B minus your probability of A and B. Right. On this question, we're given that the probability of A or B is 0.57. So you substitute 0.57 equals to your probability of A. You know that your probability of A, we do not know on this question the probability of A. So you could just substitute the probability of A. And then your probability of B, it is given that it's 2 times your probability of A minus the probability of A and B. Because these events are mutually exclusive, it's going to be your 0, and then you've got 0.57 being equal to your probability of A plus 2 times probability of A. It's going to be 3 times your probability of A, and then simply solve for the probability of A, and you get the probability of A being 0.19. But the question does not ask you to find the probability of A. They are looking for your probability of B. From the question again, you know that the probability of B is going to be 2 times your probability of A. Bear in mind, we've already calculated the probability of A being 0.19, and then you get 0.38 as your final answer. There's also another way you could have substituted in this equation by simply making probability of A being the subject of a formula from here, and you were going to have you were going to substitute your probability of A being probability of B divided by 2 plus the probability of B, and then you'll end up having your fractions. So I was just trying to do away with fractions because some of us might do some mistakes when you deal with fractions. Okay, we've calculated this question, and yeah, I think we'll do 9.2 on the next video.